Assalamualaikum. Alright, in this video we are going to sketch the graph of polynomials using the differentiation, which is the application of differentiation. Alright, so firstly, before we go to the examples for the graph of polynomials, so we have to know some basic ideas, some basic concepts of this sketching of graph. The first one, we have to know about the x-intercept and also y-intercept. So if we want to find the x-intercept, so it must be y equal to 0, and if it is y-intercept, and then we'll have to let x equal to 0, so we get the value of y. Right, so that's the concept of interception, so you have to remember that. Next, we're going to look at the slope of the functions, or we want to look at the function whether it is increasing or decreasing. So if the f prime x is greater than 0, which is a positive number, so it is actually increasing. All right, so the slope will be slanting to the right. Okay, but if it is f prime x, the first derivative is less than 0, which is the negative number, you get negative number on that certain intervals, then it will be decreasing, or the slope is slanting to the left. Okay, and then we have the concept of concavity. So for the concavity, we have to find the second derivative, meaning that we have to differentiate the function twice. So f double prime x is greater than equal to is greater than 0, so it should be concaving up. All right, meaning that it's concave up. All right, so if it is f double prime of x less than 0, which is a negative number, it will be concaving down. All right, so the shape of the graph should be like this. All right, so to illustrate this increasing and decreasing and also concavity, I would like to show this part. All right, so from this, all right, so from this to this, we look at the function is actually increasing. All right, so it's increasing. I'll call this increasing. And then from this blue interval to this is actually decreasing. All right, and then we note that from this to this is going to increase again. All right, and then it's decreasing there. All right, and then it is increasing again. Right, that's the meaning of increasing and decreasing functions. So to determine this, f prime f is greater than 0. So to do this, f prime is less than 0. But now we're going to look at the concavity, where the concavity is the shape of the curve. So in this case, all right, we look at this curve, the first, right, from this to this, it is actually concaving down. All right, it's concaving down. But from this point onwards, it goes to this point, it is concaving up, something like this, right? So the point where the concavity changes from concaving down to concaving up, we call this as inflection point, right? So we call this as inflection point. Inflection point is the point where the graph is changing the concavity, right? So again, from this to this, we are getting the concaving down. All right, so this is actually concaving down because it's, you know, it's like a rokok. All right, or rokok like that. All right, so we still call this inflection point. So I'm calling this inflection point because the concavity is changing from the concave up to the concaving down. All right, so now again, this is also concave inflection point because the concavity from concave down is going to change to concaving up. All right, so something like this. So that's the concavity and also inflection. Slope. Okay, so next we're going to look at the extremum point. So if the equations ask us to find the extremum points, meaning to say that we have to find the maximum point or the minimum point. So to do this, so we have to let dy over dx is equal to 0, or if we are using the function fx, so f prime of x should be equal to 0, and that will get the point of x. Then we'll have to find the value of y, and we get the maximum or minimum. So to determine the maximum or minimum, later on we'll see. All right, so we note that, all right, sometimes these maximum points are called as turning point. So because it's turning points, okay, let's say this is them. All right, so what's meant by maximum? All right, this point is a maximum, and this point is the minimum, and this point can be maximum there. All right, So the turning point, why the turning point? All right, so let's say I'm sketching another graph here. All right, so why we call this as turning point? All right, because it is turning, all right, from like this, all right, from there, what do we call that, increasing function to the decreasing function. That one is called as turning point. All right, so sometimes it's called stationary point because the graph is moving up to this point and then it stops. All right, it stopped and stopped, so that's why it's called stationary point, and then it will go up again. All right, something like that. Okay, so now the next idea is on the critical points, where the critical points is almost the same as extreme points. If f prime of x is equal to 0, and then we get the critical points, which is, for this case, this is actually the case where we have to find the maximum and minimum point. But for critical points also, we have to consider the f prime as not differentiable. So to illustrate this, let's see this example. We're given with this, so we're gonna differentiate this, so we'll get 2x plus 3. So we'll have to let the f prime x equal to 0. So 2x plus 3 equal to 0. X equal to -3/2. So this is called as the critical points, or we can find the extremum point from this point. All right, so to find the point, all right, so to get the y, so we have to substitute into the initial function, not into this one, not. Okay, right, so you can find the value of y. Okay, so you get the point, because the point should be in the coordinate. All right, let's look at the second example here. If we have this function, so I differentiate this, we'll get half of x to the power -1/2 minus 3/2 x to the power -3/2, and then we try to factorize the x to the power of, maybe I can factorize half of, what do we call that, x to the power of -3/2. All right, okay, let's say I factorize this, so I'll get x, okay, 1 minus, all right, so I'll get x minus 3. Am I right? Yeah, something like this. Okay, so 1 minus 3/2. Yes, all right, so that's minus 3. So if we rewrite this in the form of x minus 3/2 x to the power of 3/2, we note that, all right, so we'll have the first f prime x equal to 0 if and only if, all right, the value of this function, when will this f prime x will become 0? When x is equal to 3. All right, when x equal to 3. So x equal to 3 is a critical point. Another critical point that we have to consider is that, all right, if we try to substitute the value of x here with 0, we'll get the infinity, right? Because something over 0 will go to infinity. So meaning that it's undefined there. So meaning that we cannot differentiate the value as the fx at x equal to 0. Because if we try to substitute the value of x with 0 here, when x is equal to 0, so the function will be undefined, meaning to say that the function is not differentiable at x equal to 0. So when the function is not differentiable, is, all right, f prime x, all right, fx not differentiable, all right, sorry, fx not differentiable, all right, fx not differentiable there. So that means that we have two critical points here. The first one is x equal to 3, another one is x equal to 0. All right, so let's see the first example and sketching the function of quadratic function here. All right, this one is very easy. All right, so firstly we have to find the x-intercept when y equal to 0. So we'll have to let the x squared minus 6x minus 7 equal to 0. So solving this, all right, using, or what do we call that, factorization, x minus 7 x plus 1, I guess, right? So am I right? Minus 7, all right, so we'll get x equal to 7, another one x equal to -1. Okay, so next one, we're gonna find the y-intercept. When we will find the y-intercept, so when x is equal to 0. All right, so this one I'm writing here. When x is equal to 0, so our fx will be, or we can write y will be, all right, we're substituting x with 0 here, so we'll get y equal -7. Okay, So that is x-intercept and y-intercept. Right, so next we're going to find a interval where the function is increasing or decreasing. So to do that, we'll have to differentiate the what do we call the function first. All right, I'm going to differentiate these. So in this case here, f prime x is given by 2x minus 6. So after differentiating this, I'll have to let f prime x equal to 0. So 2x minus 6 is equal to 0. So 2x equal to 6x is equal to 3. So this is the boundary point, all right? So meaning to say that x is equal to 3, we'll have two intervals here. One interval for x less than 3, another interval for x greater than 3. So for the interval x less than 3, which is negative infinity up to 3, another one from 3 up to infinity. So we have two intervals there. So we're going to fill up this table. So firstly, we'll have two interval only, all right? So 3 up to infinity. All right, so I'm not using this, what we call this table here, this column. All right, so now we'll have to check the f prime x over this interval. All right, so for the first interval, all right, so what is a number which is between negative 3 infinity up to 3? There are so many numbers, so we can choose any number, but don't choose the boundary point, which is 3. You don't choose 3. In this case, maybe you choose 0, which is easy. So if you try to substitute 0 inside the f, all right, we have to substitute into this function because we're going to check f prime of x. So we substitute x with 0, so we'll get negative 6, so negative number, right? So for 3 up to infinity, so you can check any number. You can take 10, or for example 2 multiplied by 10, 20, 20 minus 6, you'll get 14. So 14 is positive, so we'll check. All right, you just take any number as long as the number is within the interval. All right, so now we know that if it is negative, so it is decreasing. All right, so this one is decreasing, and if it is positive, so it is actually increasing. All right, so if you're gonna draw this, it will be something like this one is decreasing, slanting to the right, slanting to the left, but increasing, slanting to the right. And we know that the shape of the graph is something like, all right, it's going down and then it's going up, something like this. Okay, so now we have to find a what do we call, all right, let's try to find the, all right, we already have the minimum point here, all right, because it's going down, it's going up. So this is actually the minimum point. So the minimum point where at x is equal to 3, the boundary point. So to do that, all right, so I'm going to find the minimum point first. So the extremum point. So in this case, the extremum point is minimum point. So extremum point when x is equal to 3. So we're going to find the value of y. Which function do we have to use? So of course the initial function. So you substitute the value of what we call x with 3 inside this function. We'll get, all right, 3 multiplied by 3 squared minus 6 multiplied by 3 minus 7. I'll get negative 16. So the value of y is negative 16. So the minimum point in this case, all right, the minimum point is actually 3, negative 16. Okay, that's easy. All right, so now what else do we have to do? All right, we have to check the concavity. So if we differentiate this f, what do we call f prime x, so differentiating f prime x, we'll get f double prime x, which is given by, in this case, 2. Right, so 2 is a positive number, so there is no interval, so over any interval, so the value is still positive, meaning that it's always concaving up. So the shape is always like this. We don't have this kind of shape, right, for this case. All right, so this one is concaving up, so I'm gonna write concave up. So let's try to draw the graph. Right, so I'm gonna draw the graph. Note that the value of what do you call the y-intercept and x-intercept will be considered right here. Okay, let's draw a bigger graph, right, for you to see this. Okay, because the minimum point is negative 16, so we're gonna have more interval on the negative side of the y-axis. All right, so firstly we're gonna mark with, all right, so I'm gonna collect all the points. We know that the x-intercept will be at 7 and also negative 1, so I'm gonna mark at 7 and -1, so -1 and 7, all right, something like this, x and y. And then we'll have, all right, so 3, the minimum point is actually 3. All right, it's 3, I'll put somewhere around here, and -16, I'll just put -16 here. So the point will be somewhere around here. All right, so please draw it carefully, all right, nicely and neatly. All right, so I'll have the point there. So we know that from -infinity up to 3, so the function is decreasing, something like this. And from the 3 up to infinity, it will be increasing, but you must have a very smooth shape. So we know that we're gonna have what do we call that, the turning point here. So it will be something around here and passing through -1 because it is x-intercept, right? And the y-intercept is actually given by -7 here. So the value of what we call y is actually -7 here. So we're gonna draw this graph something like this, all right? So you're gonna pass through x equal to 7 there, something like this. All right, so you'll get the graph. So make sure the graph is smooth and very nice. Okay, so this is the quadratic graph, and we note that the shape of the graph is always concaving up, and we don't have any inflection point here. And also we have two intervals where the first interval of -infinity up to 3 will have the decreasing function, and from this 3 up to infinity will get increasing function. And we have this minimum point, so please label your minimum point, which is 3, -16. So we'll call this as minimum point. Okay, so I think if drawing like this, I'll go and give you full marks already, right? All right, so let's look at the next example. All right, so where we're gonna have this function. All right, so suppose we have this cubic function. So firstly, we'll have to find the what we call x-intercept. So to find the x-intercept, we know that the value of y should be 0. So we're gonna let the x to the power of 3 minus 6x squared equal to 0. I'm factorizing this. I'll get x minus 6 equal to 0. So actually, we'll have x equal to 0 and x is equal to 6. So meaning to say that the graph must pass through the x equal to 0 and also x equal to 6. For y-intercept, so for y-intercept, we're gonna have, what do we call that? The value of x must be 0. So when the value of x is equal to 0, so you substitute the value of 0 inside these two functions, as these two values, so you'll get 0. So meaning to say that the y-intercept should be 0. Alright, so now, to find the interval where the function is increasing or decreasing, we'll have to firstly differentiate the function. So differentiating the function f prime of x, we'll get 3x squared minus 12x. All right. So to find the interval, so we'll have to find the boundary point first. So we'll have to let the f prime x equal to 0. So I'm going to put 3x squared minus 12x equal to 0. Right, so I'm differentiating the 3x. Okay, I'll have something like x minus 4 equal to 0. And we know that x is equal to 0. Another point is x equal to positive 4. All right. So meaning to say that I'll have two boundary points here, which is x equal to 0 and x equal to 4. So what are the intervals here? So from this -infinity up to 0, because we don't know what number is that. All right. So for the middle interval, it will be 0 up to 4, and the last interval from 4 up to infinity. All right, so we're gonna fill up the table from -infinity up to 0, from 0 up to 4, and lastly 4 up to infinity. All right, so we're gonna check for each interval the value of f prime x, meaning to say that, all right, so let's say we have a test value, all right, from -infinity up to 0, you choose, all right, one number, -1. From 0 up to 4, okay, let's choose 1. From 4 up to infinity, I'll choose 5, let's say. So what we have to do is to check the value of f prime of x in these intervals. So we have to substitute the test value inside these functions. So firstly, we're going to substitute the value of x with -1. So when you substitute the value of x is -1, all right, so let's try. So 3 multiplied by -1 squared and then we'll have minus 12 negative 1 inside the bracket. So I get positive number, positive 15. So we'll put this as positive. Okay, so from 0 up to 4, we'll have to substitute the value of x with 1 inside the f prime x. So substitute the value of x1, we'll get negative number. So 3 minus 12, I guess, so you get negative 9. And the last one, we're going to substitute the value of x with 5. So we'll get positive 15. So we'll get positive number here. So from this sign, so we can already get the slope. For the first one, positive will be increasing. I'm going to write this as increasing. The second one will be decreasing because it is negative, right? So what is increasing or decreasing? The function fx, not f prime x is increasing, all right? The function fx. And the last one, increasing. Okay, the function is increasing or decreasing, all right? So the shape is something like, all right, I'm going to have something like this, I'm going to have something like this, and I'm going to have something like this. So from this, we clearly see that we're going to have this shape something like this, all right? I'm going to have something like that. So we'll have the maximum point here and also minimum point there. So the maximum point will be at x equal to 0, be given by this number, all right? And the minimum point will be at this point. So of course, the value of x will be 4, all right? So let's just find it directly. So if the question asks to find the extremum points, so I'm going to write the extremum points where, all right, at x equal to 0 and also 4. So first we'll try to find the value of x equal to 0. So we're going to substitute into the function. So fx will be, so we're going to substitute fx to 0, so we'll get fx equal to 0. It means f0. So f0 here, okay? And the next one, x equal to 4. So we're going to have f4. So we're going to substitute the value of x with 4. So 4 to the power of 3 minus 6 multiplied by 4 square will get negative 32. All right? So this one, negative 32. So we'll have two functions here. Two points here. 0, 0 and also 4, negative 32. Look at your y values. Which one is higher? Of course, 0 is higher than negative 32. So this one will be the maximum point as expected. Alright, so we'll get this as maximum point here. Okay, and we'll have the next one will be the minimum point. The minimum point here. Because it is negative 2, so it's going down, something like this, at x equal to 4. Alright, so that's how you find the maximum point and minimum points. So now we're going to check the concavity. So to check the concavity, we'll have to find the second derivative of the function. Right, so we're going to differentiate the f prime x again. So because f prime of x, alright, because f prime of x is given by 3x squared minus 12x. So differentiating that function will get 6x minus 12. After differentiating that, we'll have to let this f prime of x, f double prime of x is equal to 0. So we'll have something like 6x minus 12 is equal to 0. So our x will be 2. All right. So meaning to say that we're going to have an interval, a boundary point here, which is x is equal to 2. So we'll have two intervals from negative infinity up to 2, another one from 2 up to infinity. Alright, so we're going to fill up the table from negative infinity up to 2, and then we'll have from 2 up to infinity. So we're going to check the f double prime of x. Substitute the value, alright, so we're going to have a test value. So let's say 0 here, and this one will be 3. Alright, any values inside the interval, we don't care, alright, as long as it is inside the interval. So the first step, we're going to substitute the value of x with 0, so we'll get a negative number, which is negative 12 then. If you substitute the value of x with what we call 3, and then we'll get 6, which is positive values. So this one is concaving down, and this one is concaving up. Alright, so you're going to write concave down, and this one is concave up. Alright, so we see that the concavity changes. So the point at which the concavity changes, so we call this as inflection point. So how to find the inflection point at this boundary point is actually at x equal to 0. Okay, at this point x equal to x is equal to 2. So I'm gonna write when x is equal to 2, so we have to substitute the value inside the initial function, where the initial function is given by this x above 3 minus 6x squared. So f of 2 is equal to 2 to the power of 3 minus 6 of 2 to the power of 2, right, if I'm not mistaken. All right, so I'll have 8 minus 6 multiplied by 4, I'll get negative 16. So the point to negative 16 is the inflection point. All right, so we're going to use all this value. All right, so to make it easy for you, we're gonna list down. All right, you better list down the all right, so firstly we'll have the x-intercept, so x equal to 0 and x equal to 6, and then we'll have y-intercept, which y with the value of y equal to 0. And then we'll have the maximum point at 0, 0, maximum point. And then we'll have for negative 32 is the minimum point. And the last one we'll get to negative 16 is the inflection point. To negative 16. To negative 16 is the inflection point. Alright, so we're going to use all these values to draw our graph. Alright, so how to draw the graph? So look at your x-intercept 0 up to 6, alright? Alright, so we are not going to use the negative side of the x-axis, but we're going to have the what we call a lot of the negative side of the y-axis. Okay, we'll have something like this for our graph. Alright. So this is x and this is y. Please label your graph, right? Completely. Right, so we know that we're gonna have to pass through the x is equal to 0 and also x equal to 6. So I'm gonna pass, I'm gonna write 6 here. And then we'll have to pass through 4 and 2, right? So we're gonna have 0, 2, 4 and 6. All right, that would be nice. And then we'll have to pass through negative 16, also negative 32. So I'm going to write the negative 32 down here, and half of it should be somewhere around here, negative 16. Okay, so firstly we'll have to mark the maximum point. So 0, 0 is the maximum point, so I'm writing here 0, 0, this is the maximum point, right? And then I'll have 4, negative 32. So 4, negative 32 is somewhere around here. So this is 4, negative 32 is the minimum point. Okay, and then we'll have 2, negative 16. So 2, negative 16 is somewhere around here. So this is the inflection point. So 2, negative 16, this is the inflection point. Okay. Okay, so now we are going to draw the graph. We know that at the inflection point, the concavity should change from the what we call concaving down up to concave up, something like this. So we're going to have this kind of graph. All right. I don't understand. Some students kind of, okay, I see this. All right, I draw like this. Oh my God, what is this? This is a cubic graph. You should draw carefully, nicely. All right. Because you already know that this is a maximum point, meaning that you're going to have a turning point here. So we'll have this kind of shape here, because that one is maximum. If you say this is maximum, and if you draw something like, okay, I'm going something like this, what is this? This is the maximum point, not this one. All right, so be careful when drawing the graph. So this is the maximum point, meaning to say, all right, so when you draw the graph, you'll have something like, all right, I'm going to pass through this. Okay, that's the maximum. All right, so I cannot pass through, okay, more than that. No, because that one is maximum, you cannot pass through that. All right, I'm gonna turn. All right, that one is maximum already. Okay, let's turn. All right, so I'm gonna pass through this inflection point. You already draw the inflection point, but you don't pass through. That would be wrong. Okay, so you'll have to pass through the inflection point. Okay, and then we're gonna something like this. So that one is concaving down. From concaving out, we're going to change to concaving up. So we'll have to change the shape, something like this. Because this is minimum, you shouldn't go down there because it is already minimum. All right, so
we'll have to go up again and pass through 6. So we'll have something like this. But you, all right, so we'll go through this. Okay, that one doesn't pass through 6, so you should draw, all right, something that passes through 6, something like this. All right, so this is the shape. All right, if you look at your table, okay, yes, we're gonna have something like this. Okay, that's true. And then we have concavity, from concaving down from 0 up to 2. All right, yes, it's concaving down from 0 up to 2, but it started to concave up from 2 up to infinity. All right, and this is actually going up. All right, so something like this. All right, that would be nice when drawing this. So this is the cubic graph. All right, if you want to draw extension of this, all right, okay. All right, so let's move to the next question. We're gonna try the next question. Okay, what if you have this graph? When x is equal to so to find the x-intercept, so we'll have to find the value when the value of y is equal to 0. So we'll have something like negative x about 3 plus 4x squared plus 3x is equal to 0. So firstly, we can actually what do we call, factorize this. So we'll have something like x squared minus 4x plus 3. So we'll have something like x minus 3x minus 1, if I'm not mistaken. So the value of x is equal to 0, x is equal to 3, and also x is equal to, x is equal to 4, and x is equal to negative 3. So all of these are the x-intercept. Now we're going to find the y-intercept. So the y-intercept when x is equal to 0, of course, will be 0 when substituting into the functions. Alright, so next is that we have to find the interval where the function is increasing or decreasing. So to do that, we'll have to differentiate the function. So f prime of x will be, alright, negative 3x squared, alright, plus 8x plus 3. Okay, we have something like this. So what we have to do next is to find the f prime of x is equal to 0. We'll have to let this function is equal to 0. So you can actually use your calculator to factorize this. Okay, negative 3 and 3. So we'll get the firstly is actually x equal to negative 1 over 3, and the last one will be x equal to 3. X is equal to 3. So this one is 3x plus 1. Please write the factorization form. Alright. Okay. So please note that we'll have two boundary points here, meaning to say that the first boundary is x equal to negative 3. The next one is x is equal to 3. So what are the intervals that can be filled up here? So the first interval should be from negative infinity up to negative 1 over 3. Next, from negative 1 over 3 up to 3, and then we're gonna have 3 up to infinity. So we can fill up the table first, from negative infinity up to negative 1 over 3, negative 1 over 3 up to 3, and then we'll have from 3 up to infinity. So next, we're gonna have the test value. For this, we can have, let's say, negative 1. For this, we can take 0, which is the easiest one, and next will be 4. Okay. So we'll have to substitute all these test values, the green color, into this function because we want to check the value of f prime of x, right, into each interval. So firstly, we're going to choose with what we call negative 1. So we'll get negative 1, negative 3, all right. So plus 8 multiplied by negative 1 plus 3. We'll have negative 8. So that one is negative. So when you try to substitute with 0, you get 3, which is a positive. And I guess the last one, if you substitute the value of 4, you get negative. Right? 8 multiplied by 4 plus 3. So negative 3 multiplied by 4 square, and then plus 8 multiplied by 4 plus 3. Okay, we get negative 13. So negative number. So we note that for the first slope, for the first one in negative, so it is actually decreasing. All right. This one is actually decreasing function. The fx is decreasing, not f prime of x. this one is increasing, all right, and this one is going to decrease again because it is negative, all right. So we'll have something like decreasing, all right, increasing, and then decreasing again. And we know that the shape is something like this. So we have the minimum point here and also maximum point there, all right. That's obvious, where at x equal to -1/3 is the minimum point and x equal to 3 is the maximum point at the boundary points there. All right, so to find that point, so I'm gonna find the extremum points. So firstly, at x, all right, at x is equal to -1/3 and also 3. So check firstly, when x is equal to -1/3, what is the value of y? So substitute into this function. Okay, we'll have to substitute into this function. So we'll have negative of -1/3 to the power of 3 plus 4 multiplied by what do you call -1/3 square plus 3 multiplied by -1/3. We'll have -14 -14/27, or somewhere on -0.5185. okay, so we'll have -1/3 and then that one is -14/27. Next, we're going to substitute the value of x with 3 into the fx. So we substitute the value of x with 3, we'll get -3 to the power of 3 plus 4, 3 square plus 3 multiplied by 3. So we'll get 18. So y is equal to 18. So another point is 318. And we know that this one is negative number, this one is positive number. Of course, that positive number is the maximum point because it is higher, right? So, and also it's obvious that this point should be the maximum point. So this one is the maximum point and this one is the minimum point, all right? So next, we're going to check the concavity. So to check the concavity, we'll have to differentiate f prime of x again. So in this case, we'll get something like f double prime of x is given by -6x plus 8, right? -6x plus 8. So to check the boundary point, so we'll have to, what we call, let this equal to 0. Okay, so 6x, which is equal to 8, then x is equal to 4/3. So the boundary point should be 4/3, meaning to say that we'll have two intervals here. So this is 4/3. So of course we'll have the first interval from -infinity up to 4/3, and the last one from 4/3 up to infinity. So we'll have -infinity up to 4/3. All right, so from 4/3 up to infinity. So we're gonna check that. So we're gonna have the test value. So take any value inside this function, this interval 0. All right, this one can be 4/3 is already 1/3. So you can take 2, right? For which is easy for us. So substitute the value of 0 inside this function, we'll get +8, so that one will be positive. We start to substitute the value of x with 2, I get -12 plus 8, so I get -4, so negative. So we know that this one is concaving up, and this one is concave down. Alright, the shape is something like this. This one is concaving up, and this one is concaving down. And we already know that the shape is something like this. Concaving up and then concaving down. All right, so we already have all right, so because there's a change in the concavity, we'll have to find the inflection point. So to find the inflection point when x is equal to 4/3, all right, so of course at this point, when x is equal to 4/3, we're going to substitute the 4/3 into the fx. So f of 1/3 we'll get 4/3, sorry, 4/3. We'll just substitute the 4/3 into the function. So -4/3 to the power of 3 plus 4/3 to the power of 2 plus 3 4/3. So we'll have, okay, the value is actually given by 236/27, or we can write in the decimal, which is 8.74. All right, so the inflection point is given by 4/3 236/27 is the inflection point. Right, so to draw this graph, okay, so we're gonna have all the value first. All right, I'm gonna list. So we'll have x0, -3, -3, 0, and 4. Okay, so we have x, which is given by -3, 0, and 4. All these are the x-intercept, and then we'll have y-intercept, which is given by 0. And then we have the maximum minimum point, which is given by these values. So -1/3, -14/27. This one is the minimum point, and we'll have 318, which is the maximum point, and the last one will get inflection point, which is given by this point, 4/3 to 36/27. So we'll have 4/3 to 36/27. That one is the inflection point. All right, so when we have all these values, we can draw the graph. So we know that the graph is okay, should include the negative part of x also, and it is more towards positive side of the y-axis, right? Never mind, I'll just draw the symmetric axis like this, something like this. Okay, so we'll have y, which is equal to, this one is x. Okay, so it should pass through -3, 0, and 4. So I'm gonna mark the -3, 0, and 4 first. So this is 0, -3 should be somewhere around here, and 4 should be somewhere around here. Okay, and then we'll have -1, sorry, we'll go to 0. Okay, -1/3. So -1/3, maybe I can put somewhere around here, -1/3. And then we'll have 3. Maybe I can say it somewhere around here. And then I'll have the 4/3, which is 1/3. So 1/3, maybe somewhere around here, 4/3, right? We just have to kind of estimate this on the axis. All right, and then we'll have -14/27, which is given by actually this -0.5. So somewhere around, maybe I can put it somewhere around here. This one is -14, or maybe I can put down a little bit. All right, -14/27, and then we'll have 18. Right, so 18. Okay, let's say this is the maximum point, so that one is 236, is the inflection point, 8.74, maybe in the middle, somewhere around there. Right, so that one is 236/27. So we'll have to mark the points first. Right, so the minimum point should be -1/3, -14/27. So I'm going to put the minimum point here. Right, next one I'll have 318. So 318, this will be the maximum point. The maximum point should be somewhere around there. And then I'll have 4/3. All right, so 4/3, this one is the inflection point. Okay, so okay, we already have all these values. All right, so some students, I also don't get, I cannot bring in how students do this. Okay, you see these 3 points. Okay, I'm going to connect this. Done. What is this? All right, if you're going to draw something like that, we're going to kick you out. All right, so what you should do, you know that this is the maximum point, which is given by, this is the maximum point, and this is the minimum point. You cannot go beyond that. All right, so if it is the minimum point, we know that this is the, what we call the x-intercept, so it must pass through that point. Okay, something like this. All right, so some students having problem here, right? When they see, all right, so sir, where should I go? Somewhere around here? No, because you already said that it passed through the y-axis, which is equal to 0, so you should go somewhere around here, right? Maybe this graph is not really what do we call, it's not really nice here. All right, okay, it's not that nice. Okay, but okay, I'm gonna start here first. I'm gonna draw this somewhere around this. All right, So that minimum point shouldn't be there, right? Because that's not quite nice there. Right, I'm going to redraw the graph. Okay, I'm going to put that, what do we call this, -4 over, I'm going to put here -14 over -7. Okay, okay, that will be somewhere around here. I'm going to put that -1 over 3 here. Okay, because I want to make the shape of the graph better. So you can change when you draw the graph. All right, you can change the points. Okay, something like this, and you must pass through this, what we call 4. Okay, so we'll have this graph, right? So we note that it is concaving up, and then it will become concaving down, and we have the inflection point here. Okay, inflection. All right, so basically this is what you have to do when you want to sketch the polynomial graph. So in the next video, I'm going to show you how to draw the reciprocal graph. Right, so thank you for watching.